students, in the last we discussed about group 16 elements. So under that first we learned about the oxygen family. So before going to that next element, that is sulfur, so we learned about oxides, right? Under that we have three major classification anta helide. Actually we have four classification, that is in third one, that is neutral oxides. It is not a neutral, it is amphoteric oxides, which acts as a both, okay na, which is both acidic in nature as well as in basic nature, that is amphoteric oxides. Whereas you have one more, that is neutral oxides which neither acts as acid or base, okay na. So ಅದು even act ಆಗಿ acid ಆಗು act ಮಾಡಲ್ಲ and even base ಆಗು act ಮಾಡಲ್ಲ. So neither acts as a acid nor as a base. So such type of oxides are called as neutral oxides, that is neither acid or base, okay na. So we have an example, that is carbon monoxide, then nitric oxide, okay na. So we have several examples for neutral oxides, and even N2O, dinitrogen oxides. So these are the examples for neutral oxide. So overall we have four classification: acidic, basic, amphoteric and neutral. So acidic, which gives acid with respect to water. So water jothe treat ಮಾಡಿದಾಗ ನಮಗೆ it gives acid. So generally non-metals are acidic in nature, okay na. Whereas basic oxides, which gives base with respect to water. So generally alkali metals, alkaline earth metals and some transition elements, some transition metals acts as a basic oxides, okay na. Then amphoteric oxides, which acts both acid as well as base. Whereas neutral oxides, which neither acts as a acid or base, okay na. So this is about the oxides. Under oxygen family we learn two compounds, that is dioxygen and ozone, right? So next coming to the second element in group 16 element, that is sulphur, okay na. The second element present in group 16, that is sulphur. So sulphur, we have a symbol S. Actually it is a octaatomic, okay na. S8 anta ನಾವು ಮೆನ್ಷನ್ ಮಾಡ್ತೀವಿ. So it is a polyatomic ಅಂತ ಹೇಳ್ಬೋದು, or octaatomic ಅಂತ ಹೇಳಿ ಹೇಳ್ಬೋದು. Clear? So this sulphur exists in several allotropic forms, as mainly we have yellow rhombic sulphur and monoclinic forms, okay na. So usually ನಮಗೇನಂತಂದರೆ we have two major allotropic forms, that is rhombic sulphur and monoclinic sulphur, okay na. Rhombic and monoclinic sulphur. So rhombic sulphur commonly called as alpha sulphur, whereas monoclinic sulphur commonly called as beta sulphur, okay na. So we have these two forms, very important. So we have a comparative study, that is the difference between the rhombic sulphur and monoclinic sulphur. Usually this rhombic sulphur, it is prepared by slowly evaporating of solution of carbon disulfide, okay na. So alpha sulphur, beta sulphur, firstly it is slowly evaporating process of sulphur in carbon disulfide, okay na. So carbon disulfide ಅಲ್ಲಿ ನಾವು ಇದನ್ನು ಪ್ರಿಪೇರ್ ಮಾಡ್ತೀವಿ, ಕ್ಲಿಯರ್. ವೆರಾಸ್ monoclinic, that is beta sulphur ಅಂತ ಬಂದ ತಕ್ಷಣ, it is prepared by a particular method. So ಫಸ್ಟ್ ಏನಾಗುತ್ತೆ ಅಂತಂದರೆ, we are going to melt the rhombic sulphur in a china dish. ಸೊ ಚೈನಾ ಡಿಶ್ ಅಂತ ಒಂದು ಆಪರೇಟರ್ ಸಿಗುತ್ತೆ. ಸೊ ದೇರ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಮೆಲ್ಟ್ ದಿ ರಾಂಬಿಕ್ ಸಲ್ಫರ್, ದಟ್ ಈಸ್ ಆಲ್ಫಾ ಸಲ್ಫರ್ನ ನಾವು ಅದನ್ನು ಮೆಲ್ಟ್ ಮಾಡ್ತೀವಿ. ಮೆಲ್ಟ್ ಮಾಡಾದಮೇಲೆ ವಿ ಆರ್ ದ ಮೋಲ್ಟನ್ ಸಲ್ಫರ್ ಈಸ್ ಅಲೋಡ್ ಟು ಕೂಲ್ ಲೆಟ್ ಟಿಲ್ ದಿ ಕ್ರಸ್ಟ್ ಈಸ್ ಫಾರ್ಮ್ಡ್, ಓಕೆನಾ. ಕೂಲ್ ಆದಮೇಲೆ ಅದು ಕ್ರಿಸ್ಟಲ್ ಥರ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ, ಓಕೆನಾ. ಸೊ ಆ ರೀತಿ ನಾವು ಅದನ್ನು ಏನು ಮಾಡ್ತೀವಿ, ಕೂಲ್ ಮಾಡ್ತೀವಿ. ಸೊ ನೆಕ್ಸ್ಟು 2 ಹೋಲ್ಸ್ ಆರ್ ಮೇಡ್ ಇನ್ ದಿ ಕ್ರಸ್ಟ್. ಸೊ ಆ ಮಿಕ್ಸರ್ ಏನಿದೆ ಅದು, ಆ ಫಾರ್ಮ್ ಏನಿದೆ ಅದರಲ್ಲಿ ನಾವು 2 ಹೋಲ್ಸ್ನ ಮಾಡ್ತೀವಿ. ಸೊ 2 ಹೋಲ್ಸ್ನ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಅಲ್ಲಿರ್ತಕ್ಕಂಥ ಸಮ್ ಅಮೌಂಟ್ ಲಿಕ್ವಿಡ್ ಏನಾದ್ರು ಇದ್ದರೆ ಅದನ್ನು ನಾವು ಪೋರ್ ಮಾಡಿಬಿಡ್ಬೋದು. ಟು ಸೇ ಡ್ರೈ ಆಗಬೇಕು, ಕಂಪ್ಲೀಟ್ಲಿ ಡ್ರೈ ಆಗಬೇಕು. ಸೊ ಆನ್ ರಿಮೂವಿಂಗ್ ದ ಕ್ರಸ್ಟ್, ಕಲರ್ಲೆಸ್ ನೀಡಲ್ ಶೇಪ್ಡ್ ಕ್ರಿಸ್ಟಲ್ಸ್ ಆಫ್ ಬೀಟಾ ಸಲ್ಫರ್ ಆರ್ ಫಾರ್ಮ್ಡ್, ಓಕೆನಾ. ಸೊ ಆ ಕ್ರಸ್ಟ್ನ ನಾವು ಏನು ಮಾಡ್ತೀವಿ, ಆ ಕಂಪ್ಲೀಟ್ ಲಿಕ್ವಿಡ್ನ ರಿಮೂವ್ ಮಾಡಿದಾಗ ನಮಗೆ ಆ ಕಲರ್ಲೆಸ್ ನೀಡಲ್ ಶೇಪ್ಡ್ ಕ್ರಿಸ್ಟಲ್ಸ್ ನಮಗೆ ಸಿಕ್ಕುತ್ತೆ. ದಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಬೀಟಾ ಸಲ್ಫರ್. ಓಕೆನಾ. ಸೊ ದಿಸ್ ಇಸ್ ಪ್ರಿಪೇರ್ಡ್ ಬೈ melting alpha sulfur. Okay na. So alpha sulfur is prepared by what? Slowly evaporating of sulfur in carbon disulfide. Okay na. Sulfur in carbon disulfide, whereas beta sulfur anta bandaga we are going to take melting the alpha sulfur. Okay na. Aa process enide aa reeti ಮಾಡ್ತೀವಿ. Next this alpha sulfur that is insoluble in water, insoluble in water and highly soluble in carbon disulfide. Okay na. Whereas beta sulfur, it is insoluble in water and soluble in carbon disulfide. Okay na. Whereas next we have property that is most stable form of sulfur at room temperature. Okay na. So it is stable at room temperature, that is above 369 temperature. Okay na. So most stable anta ಹೇಳ್ತೀವಿ, but above 369 ಆದಾಗ it transfers to beta sulfur. Okay na. So most stable sulfur is what? Alpha sulfur, but above, if it reaches above 369 Kelvin, it forms beta sulfur. Okay na. Whereas it is stable above 369 temperature and transfers to alpha sulfur below that. Okay na. So below 369 Kelvin idre it will forms alpha sulfur. Understood? ಸೊ ಏನಂತಂದರೆ ಮೋಸ್ಟ್ ಸ್ಟೇಬಲ್ ಅಂತ ಬಂದರೆ ನಮಗೆ ಆಲ್ಫಾ ಸಲ್ಫರ್ ಇರುತ್ತೆ, ಬಟ್ ಇಟ್ ಅಬೋವ್ 369 ಬಂದಾಗ ಇಟ್ ಫಾರ್ಮ್ಸ್ ಬೀಟಾ ಸಲ್ಫರ್. ಸೇಮ್ ಇಲ್ಲೂ ಅಷ್ಟೇ, ಇಟ್ ಈಸ್ ಆಲ್ಸೋ ಸ್ಟೇಬಲ್ ಅಪ್ ಟು ವಾಟ್ ಅಬೋವ್ 369 ಕೆಲ್ವಿನ್. ಬಿಲೋ 369 ಅಂತ ಬಂದಾಗ ಇಟ್ ವಿಲ್ ಟ್ರಾನ್ಸ್ಫರ್ ಟು ಆಲ್ಫಾ ಸಲ್ಫರ್. ನೆಕ್ಸ್ಟ್ it consists of S8 ಪಕರ್ಡ್ ರಿಂಗ್ಸ್ ಅಂತೇಳಿ ಹೇಳ್ತೀವಿ. ಓಕೆನಾ. ಸೊ ದಟ್ ರಿಂಗ್ ಸ್ಟ್ರಕ್ಚರ್ ನಾನು ನಿಮಗೆ ಹೇಳ್ಕೊಡ್ತೀನಿ. ಸೊ S8 ಅಂತೇಳಿ ಆಕ್ಟಾ ಅಟಾಮಿಕ್ ಅಂತೇಳಿ ಹೇಳ್ತೀವಿ. ಇಟ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ಎ ಕ್ರೌನ್ ಶೇಪ್ ಆರ್ ರಿಂಗ್ ಶೇಪ್, ಕ್ಲೋಸ್ಲಿ ಪ್ಯಾಕ್ಡ್ ಸ್ಟ್ರಕ್ಚರ್ ಥರ ಇರುತ್ತೆ. ಓಕೆನಾ. ಕ್ಲೋಸ್ಡ್ ಶೇಪ್ ಇರುತ್ತೆ. ಸೊ ಕ್ರೌನ್ ಶೇಪ್ ಇರ್ಬೋದು ಅಥವಾ ರಿಂಗ್ ಶೇಪಲ್ಲಿ ಇರ್ಬೋದು. ಕ್ಲಿಯರ್. ವೆರಾಸ್ ನಮಗೆ ಬೀಟಾ ಸಲ್ಫರ್ ದಟ್ ಈಸ್ ಮೊನೋಕ್ಲಿನಿಕ್ ಸಲ್ಫರ್ ಅಂತ ಬಂದರೆ ಇಟ್ ಕನ್ಸಿಸ್ಟ್ ಆಫ್ ಅಗೈನ್ S8 molecules, S8 atoms. So here we are having a crown shape. Okay na. So but the rings are less closely packed, comparatively namige less closely irutte. Illi more closely packed structure, whereas less closely packed structure in case of beta sulfur. ಕ್ಲಿಯರ್. ಸೊ ಕಮಿಂಗ್ ಟು ದಿ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ನಮಗೆ ವಿ ಹ್ಯಾವ್ ಟೂ ಪಕರ್ಡ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್, ದಟ್ ಈಸ್ ಕ್ರೌನ್ ಶೇಪ್ ಆ್ಯಂಡ್ ಚೇರ್ ಶೇಪ್ ಅಂತ ಹೇಳಿ, ಚೇರ್ ಫಾರ್ಮ್ ಅಥವಾ ರಿಂಗ್ ಫಾರ್ಮ್ ಅಂತೇಳಿ ಹೇಳ್ತೀವಿ. ಸೊ ಪರ್ಟಿಕ್ಯುಲರ್ಲಿ ಹಿಯರ್ ದ 369 Kelvin temperature we are going to call it as transition temperature. Okay na. So above 369 idre namigeno that becomes beta sulfur, below 369 anta bandre that becomes alpha sulfur. Okay na. So 369 Kelvin, this is the transition temperature. So transition temperature illi particularly above this temperature idre it will form beta sulfur, whereas below 369 idre namige alpha sulfur anteli heltivi. Hence 369 is the transition temperature. Okay na. So in gaseous state sulfur partly exist as S2 molecules, means gaseous state ಇದ್ದಾಗ ನಮಗೇನಾಗುತ್ತೆ ಸಲ್ಫರ್ ಆ್ಯಕ್ಟ್ಸ್ ಆಸ್ ಎ S2 ಫಾರ್ಮ್, ಐ ಮೀನ್ S8 ಬದಲು ಆಕ್ಟಾಟಮಿಕ್ ಬದಲು ಡಯಾಟಮಿಕ್ ಆಗಿ ಬಿಹೇವ್ ಮಾಡುತ್ತೆ, ವಿಚ್ ಹ್ಯಾಸ್ 2 ಅನ್ಪೇರ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇನ್ ದಿ ಆ್ಯಂಟಿ ಬಾಂಡಿಂಗ್ ಪೈ ಸ್ಟಾರ್ ಆರ್ಬಿಟಲ್ಸ್ ಲೈಕ್ ಆಕ್ಸಿಜನ್. ಸೊ ನೀವು ಫಸ್ಟ್ ಪಿ ಯು ಅಲ್ಲಿ ಮಾಲಿಕ್ಯುಲರ್ ಆರ್ಬಿಟಲ್ ಥಿಯರಿ ಕಲ್ತಿದ್ದೀರ ಅಲ್ವಾ. ಸೊ ಅಲ್ಲಿ ನಿಮಗೆ ಬಾಂಡಿಂಗ್ ಮಾಲಿಕ್ಯುಲರ್ ಆರ್ಬಿಟಲ್, ಆ್ಯಂಟಿ ಬಾಂಡಿಂಗ್ BMO ABMO ಅಂತ ಹೇಳಿ ನೋಡಿದ್ದೀರಾ. ಸೊ ಆ್ಯಂಟಿ ಬಾಂಡಿಂಗ್ ಇದ್ದಾಗ ನಾವು ಸ್ಟಾರಿಂದ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ದೇರ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ 2 ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್, ಓಕೆನಾ, ಲೈಕ್ ಆಕ್ಸಿಜನ್. ಕ್ಲಿಯರ್? ಆ್ಯಂಡ್ ಹೆನ್ಸ್ ಇಟ್ ಆ್ಯಕ್ಟ್ಸ್ ಆಸ್ ಎ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಸಮ್. ಕ್ಲಿಯರ್? ಓಕೆ. So students, the two puckered structures are like this, okay na, it is in S8 form and S6 form, okay na. So particularly S8 form, so here the structure is crown shaped, okay na, crown shaped anta heli heltivi. Here we have a bond length that is 200 pm, whereas bond angle 107 degree, whereas S6 form anta banda takshana it is a chair form, okay na. This is a crown form, this is a chair form. Here the bond angle is 205.7 pm, whereas bond length is 205.7 pm, whereas bond angle is 102.2 degree. Clear? So these two are the puckered structure which exist in crown form as well as in chair forms, okay na. Coming to the compound of sulfur, that is, firstly we have sulfur dioxide. You have two compounds, that is sulfur dioxide and sulfuric acid. So firstly we are going to study about the sulfur dioxide. So coming to the preparation, that is, firstly we are going to prepare directly, that is by heating sulfur in presence of oxygen, we are going to get sulfur dioxide, okay na. So direct combination reaction, sulfur is burnt in presence of air or oxygen, sulfur dioxide is formed. Coming to the laboratory method, that is we are going to treat, that is NaSO3, sodium sulphite, with H2SO4, we are going to get SO2, then sodium sulphate, then water, okay na. So sodium sulphite, this is sodium sulphite. Sodium sulphite now H2SO4 ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಿದಾಗ we are going to get sulfur dioxide and sodium sulphate and water, okay na. Nextly we have industrial method of, I mean to say in the large scale, we are going to prepare sulfur dioxide by simple roasting sulfide ores, okay na. So sulfide ores, any sulfide ore, here we have an example, that is iron sulfide, so that is commonly called as iron pyrites, that is FeS2, okay na, iron pyrites. This undergo heating in presence of oxygen or air, we are going to get Fe2O3 plus 8SO2, okay na, we are going to get sulfur dioxide. Clear? So from any sulfide ores we can prepare sulfur dioxide. So here we have example, that is from iron pyrites, undergo burning process in presence of oxygen or air, we are going to get sulfur dioxide as a byproduct. Clear? Next, coming to properties. Firstly we have physical property. So it is a colorless gas with a pungent odor. It is a highly soluble in water and it can be liquefied under pressure, okay na. So it is a colorless gas with a pungent odor, it is highly soluble in water and it can be liquefied under pressure, okay na, it is a liquefiable gas. Coming to chemical properties, that is, firstly we have acidic nature. Chemical properties. So when sulfur dioxide is passed through water, it reacts with water to form sulfurous acid, H2SO3. Clear? Sulfurous acid. So sulfur dioxide is passed through the water, it will form sulfurous acid. Similarly, sulfur dioxide combines with base, that is NaOH, alkali, it will form Na2SO3 plus H2O. Okay, so sulfur dioxide combines with alkali, that is sodium hydroxide, it will form sodium sulphite and water. Again, that sodium sulphite reacts with further sulfur dioxide in presence of water, we are going to get sodium bisulfite. Okay na? Sodium bisulfite. So clear. So the acidic nature anta consider ಮಾಡಿದಾಗ sulfur combines with water to form sulfurous acid. Okay na? Highly acidic in nature ಅಂತ ಹೇಳ್ಬೋದು. So sulfur dioxide reacts with sodium hydroxide, that is alkali. It will form sodium sulfite, whereas again that sodium sulfite formed further reacts with few more sulfur dioxide in presence of water to form sodium bisulfite. Clear? So this is about the acidic nature of the sulfur dioxide. Next, coming to addition reaction, how it reacts with other elements. Okay na? So addition reaction. So here sulfur dioxide is treated with chlorine gas. So chlorine gas jothe treat ಮಾಡಿದಾಗ we are going to get SO2Cl2. So this we call it as thionyl chloride ಅಂತ ಕರಿತೀವಿ. Clear? So thionyl chloride or sulfonyl chloride ಅಂತಲೂ ಹೇಳ್ಬೋದು. ನೆಕ್ಸ್ಟ್ ದಿಸ್ ಸಲ್ಫರ್ ಡೈಆಕ್ಸೈಡ್ combines with oxygen in presence of V2O5. It is a catalytic reaction. So in presence of V2O5, sulfur dioxide combines with oxygen to form sulfur trioxide. Okay na? This is how it reacts with chlorine and oxygen. So in presence of chlorine, sulfur dioxide reacts with chlorine. In presence of charcoal, it will form thionyl chloride, whereas sulfur dioxide reacts with oxygen in presence of V2O5. So it is a catalytic reaction. It will form sulfur trioxide. So this is about the addition reaction. Next we have reducing action. So how it reduces or how it behaves as a reducing agent. So next we have reducing action of sulfur dioxide. Actually sulfur dioxide, it is a good reducing agent. Okay na? So here we have a reaction that is ferric sulfate. Okay na? So ferric sulfate irodu namige ferrous sulfate agi form agutte. I mean reduce agutte. So in presence of moist SO2, this ferric sulfate get reduced to ferrous sulfate. Next we have one more example, that is KMnO4, potassium permanganate, that is purple color. Okay na? So it will reduce us to manganese sulfate, that is colorless. Clear? So purple color, that is colored KMnO4, reduced to colorless manganese sulfate, that is MnSO4, in presence of sulfur dioxide. Hence in these two conditions, that is ferric sulfate reduces to ferrous sulfate and this potassium permanganate reduces to manganese sulfate, that is coloration get decolorizes. Clear? So in these two cases, here sulfur dioxide acts as a good reducing agent. Clear? So this is about the reducing action of sulfur dioxide. So next we have structure of sulfur dioxide. So as we already know, here we have one sulfur atom and two oxygen atom. So S double bond O, S single bond O. Okay na? So here we have two canonical forms or resonance structures ಅಂತ ಹೇಳಿ ಹೇಳ್ಬೋದು. ಸೊ ಎಸ್ ಅಂತ ಬಂದ ತಕ್ಷಣ ನಮಗಿಲ್ಲಿ 1 2 3 4 5 6 ಇದೆ. ಸೊ ಆಕ್ಟೇಟ್ ಕಾನ್ಫಿಗ್ರೇಷನ್, ಲೈಕ್ ನೀವು ಫಸ್ಟ್ ಪಿ ಯು ಅಲ್ಲಿ ಲಿವಿಸ್ ಸಿಂಬಲ್ ಅಂತ ಹೇಳಿ ಲಿವಿಸ್ ಡಾಟ್ ಸ್ಟ್ರಕ್ಚರ್ ಅಂತ ಎಲ್ಲ ಓದಿದ್ದೀರಲ್ಲ. ಸೊ ಸಿಮಿಲರ್ಲಿ ಸಲ್ಫರಿಗೆ ಇಲ್ಲಿ 1 2 3 4 5 6 ಇದೆ. ಸೊ ದಟ್ 7 8 ಆಕ್ಟೇಟ್ ಮಾಡೋದಷ್ಟೇ. ದೆನ್ ಆಕ್ಸಿಜನ್ ಹಿಯರ್ ವಿ ಹ್ಯಾವ್ 4 5 6 7 8. ಓಕೆನಾ? ನೆಕ್ಸ್ಟ್ ಹಿಯರ್ next here we have oxygen, this oxygen 1 2 3 4 5 6 7 8, hence it is octet. Next this has one more resonance structure or canonical structure. So just namigi double bond single bond enide position ulta agutte ashtene. So same we are going to represent in the octet form. Clear? So this is about the structure of sulfur dioxide. It exists in two resonance form. Next we have uses of sulfur dioxide. Actually the main use, that is sulfur dioxide, is used in the manufacture of sulfuric acid. So it is very important, industrially important compound. There we are going to use sulfur dioxide. Then it acts as a mild bleaching agent for delicate materials such as wool, silk and all. Okay na. And even we are going to use as a disinfectant and preservative. And even we are going to use as a anti-chlor for or removing excess of chlorine in the bleached articles. Okay na. Anti-chlor ಅಂತಂತಂದರೆ ಎಕ್ಸಸ್ ಆಫ್ ಕ್ಲೋರಿನ್ ಏನಾದರೂ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಯಾವುದೋ ಒಂದು ಮಟೀರಿಯಲ್ ಅಥವಾ ಒಂದು ಸಬ್ಸ್ಟೆನ್ಸಲ್ಲಿ ಇದ್ದರೆ ಅದನ್ನು ರಿಮೂವ್ ಮಾಡಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ದಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಆ್ಯಂಟಿ-ಕ್ಲೋರ್. Then liquid sulfur dioxide is used as a solvent. Okay na. So this is about the uses of sulfur dioxide. Next, coming to oxacids of sulfur. So very important, in your exam they will ask the structure. Okay na. So totally in your syllabus you are having 4 types of oxoacids: sulfurous acid, sulfuric acid, peroxo disulfuric acid, pyrosulfuric acid. Okay na. So sulfurous acid anta bandaga we have a composition H2SO3 where sulfur contains lone pair of electrons and 2 OH group and 1 double bonded oxygen. Okay na. Whereas sulfuric acid, as you all commonly known, very important acid, so that is H2SO4. So here sulfur is the central metal atom, central atom, where we have 3 hydroxyl group and 1 oxygen atom. Then peroxo disulfuric acid, the composition is H2S2O8. So here we have 2 bridged oxygen atom. So ಎರಡು sulfur atom ಇರೋದನ್ನು ನಮಗೆ ಕಂಬೈನ್ ಆಗಲಿಕ್ಕೆ we have 2 bridged oxygen atom where both sulfur is having 2 oxygen atom and 1 hydroxyl atom. Next we have pyrosulfuric acid, that is commonly called as oleum. The composition is H2S2O7. So here also we have 2 sulfur atoms with a bridged 1 oxygen atom. Okay na. So one bridged oxygen atom ide, and each sulfur atom consists of 2 oxygen atom, I mean double bonded oxygen atom, and 1 hydroxyl atom. Clear? So this is about the oxoacids of sulfur. Next we have sulfuric acid, that I will take on next class.